In this tutorial, I'll cover all the essential C# syntax in just 6 minutes, almost everything you'll ever need to know and use. Let's start by writing your first C# program. Printing the hello world message is typically the first line of code you learn in any programming language, and you're probably tired of it if this isn't your first language. Anyway, here's how you do it in C#. Let's break this down. Console is a built-in class that handles input and output. WriteLine is a method that outputs text to the console, and Hello World is the text you'll see when you run the program. And just like that, you've written your first C# program. It's all downhill from here. Just kidding, but just wait and see it for yourself. Moving on to variables. Think of variables as labeled boxes that store information. In C#, you declare a variable with a type and name like this. Here, int holds numbers, while string holds text. Declaring a type, which is mandatory in C#, helps us avoid mistakes and ensures our program uses memory efficiently. These are all the other common data types in C#. Next, let's talk about operators. Operators are the tools you'll use to manipulate data. For example, there are arithmetic operators like plus and minus, comparison operators like greater than or less than to compare values, and logical operators like AND or OR to combine conditions. We saw strings earlier, and it's important to mention that we can format them to present information to users in a clear and readable manner. One example of string formatting in C# is using the $sign, which allows you to embed variables directly into strings. Sometimes in programming you need to convert one data type to another. This is where typecasting comes in. There are different kinds of typecasting, implicit and explicit casting, as well as built-in methods to do this. In this example, we are seeing explicit casting, which occurs when converting a larger size type to a smaller size type. This can be done using the explicit casting operator. Let's talk about handling decision-making when building programs in C#. For this purpose, we use conditional statements like if, else, and else if. These structures let your program react differently based on specific conditions. Now let's dive into arrays. One of the fundamental data structures in C# is the array. Arrays are used to store multiple values of the same type. One way to work with them is by using loops. Loops are programming constructs used to execute a block of code repeatedly as long as a specified condition is met. There are several kinds of loops, such as the for loop, for each loop, while loop, and do while loop. Moving on to methods, which are a fundamental building block in C#, designed to perform specific tasks. Methods help organize reusable blocks of code. In this example, the add method takes two parameters, a and b, performs a task, adding the two numbers, and returns a value. Methods can also have different return types, accept no parameters, or even perform tasks without returning any value. One of the main characteristics of C# is that it is an object-oriented language, which means it is built around the concept of objects and classes. Let's start by creating a simple class and an object. In this example, the car class acts as a blueprint, defining the properties and behaviors that objects of its type can have. The myCar object is an instance of the car class, initialized with a specific brand property. Objects allow you to represent real-world entities in your program, and classes help organize your code, making it reusable and easier to understand. Building on the foundation of object-oriented programming, C# supports advanced concepts like inheritance and polymorphism. Inheritance allows one class to adopt the properties and methods of another, promoting code reuse and reducing redundancy. Here, the bike class inherits the wheels property from the vehicle class. This means you can use the same property in bike without redefining it. Polymorphism then enables objects to take on many forms, allowing derived classes to define unique behaviors while maintaining a consistent interface. As we can see in this example, polymorphism is like giving each child class a unique twist while still adhering to the general behavior defined in the base class. Now let's take a look at lists and dictionaries, which are powerful data structures in C# as well that help you organize and manage data effectively. Lists are like dynamic arrays, meaning their size can grow or shrink as needed. This flexibility makes them incredibly useful for storing collections of data when the number of elements isn't fixed. Here, the add method dynamically adds an element to the list. Lists also provide other handy methods like remove, insert, and contains for managing elements. Dictionaries, on the other hand, store data as key value pairs, allowing you to retrieve values efficiently using unique keys. Dictionaries are perfect when you need to associate data like a name with an age and access it quickly. Let's wrap up with the File I/O, which stands for File Input and Output. File I/O lets you save and load data from files, so your program can keep information even after it stops running. Here's a basic example of writing to and reading from a file. If you want a more in-depth explanation of C#, you can click on the screen to watch my longer form course. I'd also highly recommend downloading my free roadmap to guide you through the right steps to become a C# and .NET developer. It will really help give you direction. Well, you can find the link below. Thank you so much for watching, and I'll see you soon.